Hello everyone, I welcome you all in this new video of mathematics. We were doing chapter number 8 of grade 9. Chapter name is Quadrilaterals. So in the last 3-4 videos we have seen the results related to quadrilaterals or parallelogram. So these are the results that we have seen with the proofs. Let me recall all these. Number 1 result is that sum of all the angles in a quadrilateral. So a quadrilateral has 4 sides, 4 angles at 4 vertices. Sum of all the angles in a quadrilateral is 360-degree. Second result is saying that a diagonal of a parallelogram divides it into two congruent triangles. Proof of each and every result we have seen. These are just the results. A diagonal of a parallelogram divides it into two congruent triangles. All these results we have to keep in mind throughout the chapter to solve the questions. Number 3 is in a parallelogram opposite sides and opposite angles are equal. So these were the two results. I have combined these. In a parallelogram, opposite sides are equal, and in a parallelogram, opposite angles are equal. So we have a collective result that opposite sides and opposite angles in a parallelogram are equal to each other. So the converse of this result is also true, which says that if in a quadrilateral opposite sides are equal, then it will form a parallelogram, and if in a quadrilateral opposite angles are equal, then it is forming a parallelogram. So written here, if in a quadrilateral opposite sides and opposite angles are equal, then it is a parallelogram. This is the converse of result number 3. So result number 4 is the diagonals of a parallelogram bisect each other. These things we have to keep in mind. The diagonals of a parallelogram means we have to keep this in mind that a diagonal of a parallelogram is dividing it into two congruent triangles, and a diagonal of a parallelogram, both the diagonals bisect each other, and vice versa means the converse is also true, that if in a quadrilateral diagonals are such that they are bisecting each other, then it is forming a parallelogram. So result number 5, we have not seen its proof yet. We'll see today in this video. Result number 5 is saying that a quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. So the result is saying if we prove that in a quadrilateral, find ABCD such that if any single pair of opposite sides, say AB and DC, if this is parallel to each other and equal to each other as well, then this is directly a parallelogram. We need to do nothing with this second pair, so we can ignore it. We will directly have a parallelogram. So these were the results. Let's see two examples we are left with and proof of this theorem. Then we'll try to proceed with the exercise 8.1 in this video. So this is example number 5. Figure is given to us. Show that the bisectors of angles of a parallelogram forms a rectangle. So this is a parallelogram given to us, and ABCD are its 4 angles. Then bisectors of these angles, this DS is bisecting angle DAS, this is A, AS is bisecting angle A. Similarly, BQ is bisecting angle B, CQ is bisecting angle C. So the bisectors of the angles of this parallelogram, we have to show that they are forming a rectangle. So we have to show that basically PSQR or PQRS is forming a rectangle. So what is given to us? Let's see the solution. ABCD is a parallelogram, so AB will be parallel to CD and AD will be parallel to CB. Now since DS is bisecting angle D, AS is bisecting angle A, therefore I have written the sum of these two angles, ADS, this angle, plus DAS, this angle. So these two angles, this angle is half of angle D, this angle is half of angle A. So I have written ADS and angle DAS is equals to, this angle is half of angle A, can be written fine, DAS is half of angle D. So we have taken this half out. Now angle A plus angle D, because this is a parallelogram, angle A plus angle D, these two lines are parallel. So if AD is acting as a transversal, then these two angles are forming a pair of co-interior angles, and when two lines are parallel, sum of co-interior angles is always 180 degree. So I can write these angles as Angle A plus angle D is equals to 180 degree. You can write a reason here, co-interior angles. Co-interior angle. So ultimately what I am getting the sum of these two angles, this angle and this angle. These two angles is 90 degree. Now to show that this is a rectangle, basically I have to show that any of the angles at the vertices of PQRS is 90 degree. And first I have to show that this is a parallelogram. Then if I show any of the angles at the vertices is 90 degree, then it will be a rectangle. How to show that this angle is 90 degree? What I will do, the sum of these two angles is now 90 degree. If I apply angle sum property in this triangle ADS, in this triangle sum of these two is 90, then 180 minus 90 is sum of I'll get angle S is equals to 90 degree. After that this angle is 90 degree, then these two are intersecting lines. This angle PSR will automatically be of 90 degree due to vertically opposite angles. Fine. So one angle will be 90 degree. Let me write these steps. Now in triangle I'll write in triangle ADS. This triangle I am saying, fine, angle ADS plus angle DAS plus angle this DSA is equals to 180 degree. Angle sum property of a triangle. Reason is angle sum property of a triangle. Fine. So sum of these two angles is 90 degree. We have just proved. So put the value here. Now DSA will be remain as it is. We'll get angle DSA is equals to 180 degree minus 90. So this will be equals to 90 degree. So I have shown that this angle is 90 degree. Therefore, angle PSR, this angle. Therefore, PSR will be equals to this angle. This angle is further equals to 90 degree. Why? Vertically opposite angles. Vertically opposite angles. When two lines intersecting, we are getting a pair of vertically opposite angles which are always equal. So this angle will be directly equals to 90 degree. Now if this angle is equals to 90 degree, then in the similar way we can also show that rest of the angles are 90 degree. Similarly, we can show angle Q is equals to angle P is equals to angle R. All these angles are 90 degree. I hope these steps are clear to you. Let's move further. If I have to show that PQRS is forming a parallelogram. So here I have proved that this angle is 90, this 90, this 90, this 90. We just have seen a result that when opposite angles of a quadrilateral are of 90 degree, then it is forming a parallelogram. We will apply that result here. Here these two angles 90 degree, these two angles 90 degree. So clearly opposite angles are equal to each other. Then it is a parallelogram. I am writing here. Let me erase the question. We will write as opposite angles in PQRS quadrilateral obviously are equal to each other. Put is equals to 19 bracket. Then it is a parallelogram. Then PQRS quadrilateral is a parallelogram proved now. So if a parallelogram is having an angle of 90 degree at any vertex, then it is a rectangle. Clearly this is having all the angles 90 degree basically. As we will write as angle S is equals to 90 degree, therefore by definition PQRS is forming a rectangle. That's it. So this was the proof. There is a parallelogram if a pair of opposite sides is parallel and equal. So if we have a quadrilateral ABCD like this, and we are given with a pair is of opposite sides is equal and parallel, means say AB is equals to CD and AB is parallel to CD. These two things we have in our hands, and we have to show that this is a parallelogram. So if we show that rest of the pair of opposite sides is parallel to each other, then we can reach to the result that ABCD is a parallelogram. Why? Because the opposite sides of a parallelogram are parallel to each other. One pair we have parallel. If we can show that the second pair is also parallel to each other, then we have the result that it is this quadrilateral is forming a parallelogram. So what we have given, AB is parallel to CD and AB is equals to CD. So we will move to these two triangles to prove them congruent. So I am taking these two triangles. I have written AC is equals to which two triangles? Let me name it as ABC and CDE. Fine, these are two triangles. Clearly AC is equals to AC. We have done so many questions like this. AC is equals to AC. Why? Because this is a common side in both the triangles. AB is equals to CD is given to us. This is again a side. This is given equals to us. And what else? Angle BAC. BAC is equals to DCA. This angle is equals to this angle. How? Because AB is parallel to CD. This is given to us. Then when the two lines are parallel and intersecting by a transversal, then pair of alternate angles are equal. So I can write pair of alternate angles. So these two angles are also equal. Now this is a side and included angle. Side and included angle. Then by SAS rule, both the triangles are congruent. We have seen that both the triangles are congruent now. Now if both the triangles are congruent, then by CPCT I can write that this angle is equals to this angle. Yes, I can write by CPCT. And when these two angles are equal, then these are again a pair of alternate angles intersecting that is equal, and two lines are intersecting by a transversal such that these two angles are equal. Then these two lines will be parallel. The result to us, when two lines are intersecting by a transversal such that a pair of alternate angles are equal, then these two lines will be parallel. So from that, clearly these two angles are equal. From that we can write AD is parallel to CD. Fine. These two angles are by CPCT equal. We can also write alternate angles in bracket. So when these two angles are equal, then these two lines will be parallel. If now we have proved that these two lines are parallel to each other, not equal, parallel to each other. These two are parallel. These we were having parallel. So therefore ABCD is a parallelogram. Hence proved. Proof was very simple. Let's see example number 6 related to the result of this theorem. Let's see example number 6. In this example, we are given with the parallelogram ABCD and P and Q are the midpoints of the side AB and CD of this parallelogram, and we have to show that this part APCQ. Let me draw this APCQ. This is also forming a parallelogram. So P is basically midpoint of AB is given and Q is midpoint of CD is given. As ABCD is a parallelogram, we have just seen a result that in a parallelogram, one side or one pair of opposite sides are parallel and equal to each other. So we can write AB is equals to CD and AB is parallel to CD. Fine. So if AB is parallel to CD, then this much part AP will obviously parallel to CQ. Fine. If I prove AP is equals to CQ, then we directly have this result that APCQ is forming a parallelogram. I have shown why AP is equals to CQ. Why? Because AB is equals to CD. Therefore, half of AB will be equals to half of CD. A better way to write. So, half of AB is what? AP and half of CD is what? CQ. So, I have proved one pair of side parallel and equal to each other of a quadrilateral, then obviously this is forming a parallelogram from the theorem 8.8. Therefore, APCQ is a parallelogram. The second part is asking us to show that this is forming a parallelogram DPBQ. In the similar way, we will proceed. We can show that DPBQ is forming a parallelogram. Fine. Third part is asking PSQR is a parallelogram. This is forming a parallelogram. This I have to show. So as SP is a part of DP. SP, this is a part of DP. We have shown in the first two results that this is a parallelogram. So these two sides are parallel. So this will be a part of this will be parallel to part of this. Fine. So this is written here. Second, to show that these two are parallel to each other. So in part number 1 we have shown that this is a parallelogram, so part of this will be parallel to the part of this side. So these two sides will be parallel. So we have shown that both the pairs of the opposite sides are parallel to each other. These are the reasons from part number 2 and part number 1. So these are parallel to each other, therefore this is forming a parallelogram. Hence proved. So 3 parts of this example we have proved. So these were 2 examples and 1 proof of the theorem 8.8. We'll see the questions in the next video. Hit like if you like, subscribe for more. Thank you for watching.